It's nice having you once again, my wonderful scholars. Jam pass question 2002. Question number 7. Two forces, each of 10 Newton, act on a body, one towards the north and the other towards the east. The magnitude and the direction of the resultant force are. Our question is centered on addition of forces or vectors. Okay, let's start. First of all, give yourself that confidence. Solution. Here we have two forces. Each has magnitude of 10 Newton and the directions were given. Recall, one is going due north and the other is going due east. What do we do? First of all, draw your cardinal point to make it easy. Draw your cardinal point. Where the journey begins is the origin. Your position begins from the origin. Okay, so the body is still here when no motion has occurred. Then let's start the motion. One force is going due north. This is north, south, west, and east. Are we together? So one force is going due north with magnitude of 10 Newton. Recall, north and east maintain the same magnitude. Then the other force is going due east with magnitude of 10 Newton. You can now see that the directions favored there. The directions favored there are north and east directions. So west and south are neglected. So focus here. The question says the magnitude and the direction of the resultant force are. We have rules of vector. Anytime that we have two vectors forming the adjacent sides of a right angle triangle, we apply triangular rule of vector. What does it say? It's a very simple denotation. It says if two vectors represent the adjacent sides of a right angle triangle, that the resultant of that vector x, the third side, which represents the hypotenuse of that right angle triangle. So this is our resultant vector. Okay, let me give you a clearer example. If a body here is being pulled by 10 Newton and also 10 Newton in the other direction, that the force moving this body is actually the force here. Whatever thing that will get here as a resultant is the actual force moving the body. This is like a struggle. Struggle between two forces of 10 Newton each at angle of 90 degrees. So the force moving the body is what we're about to get. That's the question. The resultant vector or the resultant force is the actual force moving the body. So with that, we'll know whether 10 Newton in this direction or that direction is what's moving the body, or in another direction. And I bet you it will be this one, the resultant vector. Let's solve. Then observe. To get this, we have three sides. To get that, we apply Pythagoras theorem. Triangular rule of vector, you apply Pythagoras theorem to get the resultant vector. I'll be having r squared, which is the hypotenuse, equal to opposite and adjacent square, 10 square plus 10 square. That's our Pythagoras theorem for right angle triangles. Then we forge ahead. R squared is equal to 100 plus 100. R squared is equal to 200. Recall, I'm not looking for r squared. I'm looking for the resultant force. Then r is equal to square root both sides. Square root to cancel square. Then square root here becomes 200. Recall your surd rules, square root rules. Is the same thing as, so 200 is the same as 100 times 2. Because I don't have a perfect square for 200. So we'll go using surd means or surd method. Then r is equal to, we can split the surds. We'll be having surd 100 times surd 2. Finally, we'll be having r is equal to square root of 100 is 10. Square root of surd 2 or surd 2. Square root of 2 or surd 2 remains as surd 2. So our final answer is 10 surd 2 Newton. This is the actual force moving the body. The real force moving this body is 10 surd 2 Newton. Also note, 10 surd 2 is the same as 14.14 Newton. 14.14 Newton. That is the force moving this body. Then let's know the direction the body will go. You can observe. Do you think the body will go northwards ignoring eastwards? Or do you think the body will go eastwards, ignoring northwards? Then common sense will tell you that the body will neither go on the exact plane of north or east. It will go somehow in between north and what? East. But we are yet to know the preferred angle. That's what we mean by the direction. So to do that, we have to solve. This is the angle we're looking for. That's the angle we're looking for. Okay, let's solve. To get that shape out, to be having, I already have my resultant. Northwards 10 Newton, eastwards 10 Newton. Then to get this angle theta, because this represents the vector, this is the vector, and these are s-axis. This is the resultant vector. These are x-axis. Let me know the direction this vector is acting on. That's why this is an angle of preference. Then we'll be applying Okafor. I would prefer we use the original sides. Any side you pick, you will get the same answer when you apply your Okafor. But let's go for this because we've done approximation here. So let's center on this. For this angle, this is opposite, and this is adjacent. So we'll be going for twa. Tan theta is equal to opposite is 10. Adjacent is also 10. Opposite over adjacent. Then we'll push ahead. Then I'll be having tan theta is equal to 1. Then theta is equal to tan inverse of 1. Finally, our theta is 45 degrees. So for this angle is going at exact midpoint of 90 degrees. Exact midpoint of 90 degrees. Therefore, our final answer becomes the resultant force here and its direction becomes 10 sod 2 Newton, 45 degrees east of north. What does that mean? It means that the vector or the force is acting with magnitude of 10 sod 2. That's the number, the magnitude, the size of the force at the direction of 45 degrees coming from north going to where? East. That's why I said 45 degrees east of north. Of north means it's coming from north going towards east. East of north, coming from north going towards east. You can observe the best option there is option A. 10 sod 2 Newton, 45 degrees east of north. Thank you. Stay tuned as we go ahead.